This is the first mandatory proof for trigonometry. So I just want to show you a couple of small things first before getting into it really. So if you're to imagine the unit circle, so if you don't know what the unit circle is, it's just a circle where it's going to go through the points 1, 0, 0, 1, minus 1, 0 and 0, minus 1. So it's just going around with a radius of 1 and the origin is the center. So something like that. So so make a little bit bigger here. So if you were to imagine any point that's on that unit circle, so you could put a point anywhere, but I'll put one here just for handiness sake, and then I'm just going to draw a line down to the x-axis and make a triangle with it. So if you're to imagine that angle in there, we'll just call it theta. So it could be any angle. So you're obviously that there, that's going to be the x coordinate, and somewhere across here that will be the y coordinate, wherever it goes across to there. So the distance, because it's the unit circle, so the radius is 1 everywhere. So that's the point 1, 0 there, like I said at the start. That's minus 1, 0, 0, 1, and 0, minus 1. So obviously then the radius has to be 1. So I'll put a little 1 there. So from the origin to the outside bit there is 1. Now, if you were to imagine the what sin of the angle is, so obviously that's a right angle triangle. So if you were to imagine what sin of the angle is, it would have to be whatever this side of this here, that's the opposite in that right angle triangle, it would be whatever that is, but you can see that would be actually the y coordinate. So it will be y over the hypotenuse, which is 1. So sin of theta is equal to y over 1. And then if you're to imagine what cos of theta is, that would have to be the adjacent, which is that bit there, which is the same thing as what the x coordinate is. It would be the x coordinate over 1, because the 1 is still the hypotenuse. So cos theta is equal to x, and y is equal to sine theta. So that allows us to see that any point on the unit circle would be cos theta sine theta. So we can call the coordinates of any point along it cos theta sine theta, depending on what theta is, what the angle is. So the angle will obviously change each time. So if you're to imagine this point up here, then theta would be this angle here, or so on all the way around. So I have to use that then as part of the first proof. So what we're really going to do, I'll just draw the unit circle again quickly. So what we're going to do here is, I'm just going to pick a point again, somewhere random up there, and then the origin is obviously 0. So all I'm going to do here is I'm going to find the distance between the 2 points. So I'm going to call that point up there cos theta sine theta, because we can call that cos theta sine theta because it's a point that's on the unit circle, and the center then obviously is going to be point 0, 0. And all I'm going to do is I'm going to find the distance between the 2 points, and I'm going to use this formula x2 minus x1 squared plus y2 minus y1. So you should be familiar with that formula. That's just the distance between any 2 points. So that here would be, so for the x1 y1 is 0, 0, and x2 y2 is cos theta sine theta. It would be cos theta minus 0 squared plus sine theta minus 0 squared. So that then would have to be equal to, think about it, the distance between the 2 points is obviously going to be 1, because it's just a point on the unit circle. So the zeros won't really make a difference there, so you're just going to get cos squared theta plus sine squared theta is equal to 1, and then if we just square both sides, you just get cos squared theta plus sine squared theta is equal to 1 squared, which is 1, and that's what we were asked to prove at the start. So if you're asked to prove that in an exam, you've just got to come up with something like that. You don't need to go through the first bit, obviously, over here that I went through, just showing you that the points, the coordinates are cos theta, sine theta. You can assume that, but the rest of it there, the little diagram and the proof there, that's what you need to say. So that's the first proof.